Right, so yesterday we worked on reviewing long division, which is a skill that really ties closely with dividing polynomials. We can do these same steps. So when we're doing long division, we're just going through this sequence of steps where we divide, put that answer up there, multiply it back to this, put that here, subtract, that's where we get this, bring down the next term, and then we repeat. Then we divide again. So divide, multiply, subtract, bring down the next term, and then repeat back up to divide again. So if we take a look at this one as a little review, write this one down just to review long division again. So there are a few ways to describe this question. It might say take 3,473 and divide by 6. It might look like this. So this 6 is called the divisor. The 3,473 is the dividend. And the answer we get is the quotient, and there may be a remainder with that. So we start with our divide step. So we're dividing. 3 doesn't divide in 6 or by 6, so we have to look at 2 digits. 34 divided by 6, well, 6 goes into 34 5 whole times. So then we multiply 5 times 6 to get 30. And then we subtract to get 4. And then we bring down the next term to get 47. And now we're going to repeat that process. So now we're going to take 47 divided by 6. So 6 goes into 47 7 times. And then we're going to multiply. 7 times 6 is 42. And then we're going to subtract. 47 minus 2 is 5. And then we're going to bring down the next term, the 3. So we're at 53. We're going to repeat that one more time. We're going to take what we're left with, 53, and divide it by 6. So 6 goes into 53 8 times. 8 times 6 is 48. That leaves us with 5 after we subtract. There's nothing left to bring down. If we wanted a decimal, we would put a decimal and bring down a 0 and keep going. But what we're going to do is we're going to say that's a remainder of 5. So 3,473 divided by 6 equals, okay, 500, I don't have to orient the board here, jumping all over. Let's see if it'll work. Nope, still pretty bad. So this division equals 578 with a remainder of 5. So what we can do is we can say it's 578 and 5 6. So it's the quotient plus the remainder 5 divided by the divisor 6. And what we can do is we can check that, bless you, by multiplying to see if 3,473 really does equal what we got times the 6. So basically, we're just taking and multiplying both sides of this by 6 to check our answer. So we take 6 times 578. We get 3,468. So that's what you get when you take 6 times that. And then if you distribute, 6 times 5, 6 is just 5, because the 6's cancel over there, which does equal 3,473. So we can always check our work. And we can do the same type of check when we extend this idea to polynomials. All right? So that's a review from elementary school of long division. So now, what we did yesterday is we applied those same things to dividing polynomials. And before we get into dividing polynomials, let's kind of tie this to what we've talked about with zeros and things like that. So here we have a quadratic function. The question says, find the zeros by factoring. So if I want to factor this function, since its leading coefficient is 1, I'm going to try to factor this trinomial by finding two things that multiply to negative 15 and add to negative 2. So I will get negative 5 and positive 3. This is the function rewritten in factored form, and we can find the zeros of it because the zeros are the value that make the function's value 0. And this is how we solved equations by factoring. If this equals 0, then either one of these factors is 0. So one 0 would be 5, and the other 0 would be negative 3. So we know that from factoring. So now what I'd like to do is I'd like to review target 9 a little with synthetic substitution to show you how that works. So with synthetic substitution, what I'm going to do is put one of those zeros in. So I'm basically finding f of 5. And when I do that, what should I get? Well, if 5 is really a 0, I should get 0. So let's double check that. With synthetic substitution, we put the coefficients in here. We bring down the first term, we multiply, we add, we multiply, and we add. Look at that. We get 0. If I did the same thing with the negative 3. So I bring down the 1, I multiply, I add, I multiply, and I add. I again get 0. If I had something that wasn't a 0, like in this question it's saying, is negative 5 a 0? So we can plug negative 5 in synthetically into that function. And when it's not a 0, we don't get 0 at the end. So the answer to this one is no, because f of negative 5 equals 20, not 0. A 0 is just a value that makes the function 0. Okay? Now, we did that before in target 9, but what I want you to notice is kind of a byproduct of synthetic substitution. These two things that are left actually show us the other factor. And synthetic substitution is real closely divided to division of polynomials. So let's apply that. This is that same problem. So we have x squared minus 2x minus 15, and we're dividing it by x minus 5. So we're going to do this division with long division. Now, I know what the answer is going to be. If I rewrite that numerator in its factored form, I can see what the answer is going to be. When I divide x squared minus 2x minus 15 by x minus 5, if I factor the numerator, I can see that the x minus 5s are going to cancel. So the answer to this should be x plus 3. So let's try that over here with the long division method. So the divisor, x minus 5, goes outside. X squared minus 2x minus 15 goes inside. So you always want to set it up that way. And then we're going to go through those same steps we did. Divide, multiply, subtract, bring down, and then repeat. So when I divide, I'm going to divide just the first term by the first term. X squared divided by x is x. So I put that up here above the x terms. Then I multiply that. The x gets multiplied to the divisor. So x times x minus 5. Well, if you distribute the x, you're going to get an x squared minus 5x. One thing you should always notice when you do the multiply step is this should be the same as what's right above it. That's by design. If those aren't the same, you did something wrong in your divide or your multiply steps. So then we subtract. Now this is where you have to be careful. This is back to now target 11. We're subtracting polynomials. So we're taking the x squared minus 2x minus 15 polynomial, and we're subtracting the x squared minus 5x polynomial. Which means I have to distribute that subtraction. So I could change this to plus and distribute the subtraction to both of these. So it's really x squared minus x squared, which is 0. Those should always cancel, by the way, when you subtract. But then here's where everyone makes the mistakes. It's negative 2x minus a negative 5x. I'm subtracting a negative, which I distributed the negative and changed that to adding a positive. So it's really negative 2 plus 5, which is 3x. Take out those, you can see again. Going from here, it's negative 2x minus a negative 5x. I'm subtracting a negative. So I'm adding the 5x. So this is really a positive 3x here. And then I bring down the next term, which is the negative 15. And now I'm going to repeat. So I go back to divide. I take the first term of what's left, because this is a 0. So 3x, and I divide it by the first term there. 3x divided x is 3. It's a positive 3, and this is going to be a polynomial, so I have to separate these with addition or subtraction. And then I multiply that 3 times the divisor, x minus 5. So 3 times x minus 5 is 3x minus 15. And then I subtract 3x minus 15 times it, or minus itself is 0. Anything minus itself is 0. But again, you can see that if I do 3x minus 3x, I'll get 0. And negative 15 minus a negative 15 becomes distributing that negative plus a positive. So in this case, I have a remainder of 0, and there's my answer, x plus 3. Okay, before I have you try this one, let's take a look at the next slide here, which is, maybe I won't. Let me just describe it here, because synthetic division is pretty much the same thing. So with synthetic division, I could do this exact same problem where I just use the coefficients from up here. But if I'm dividing by x minus 5, with synthetic division, I can just put the 0 out here, or the value that makes that divisor 0. So in this case, positive 5 would make the divisor 0. So then I bring down, I multiply, I add, I multiply, and I add. That verifies that it's a 0. But when I do that, look what's left. What's left are the coefficients of the polynomial answer, x plus 3. 1, x plus 3. So if I do synthetic division, and let's take a little bit of notes on that. Synthetic division is a much shorter method than long division, but it only works in certain cases. The divisor must be of the form x plus some number a or x minus some number a, where a is just some constant or number. So what you do to use synthetic division is you solve the factor equal to 0 to get the a, and then you can use synthetic substitution, basically, to do that division problem. So this example right here fits this mold. It's of the form x plus or x minus some number a. In this case, it's x plus 3. So 3 is like the a. So if I want, I can use the much easier division method to divide these two polynomials of synthetic division. Synthetic division is exactly synthetic substitution. You put the coefficients there, but this is the one thing you have to remember. You solve the divisor equal to 0. So what value of x makes the divisor equal to 0? Well, that's an easy problem. It's negative 3. So I put negative 3 out here, not positive 3. And then I bring down, I multiply, I add, I multiply, and I add. Now in this case, I do not get 0. What this tells me is if I were to plug negative 3 into this expression, I would get out 82. So what that means is when I divide these two, I have a remainder. So my answer to this division problem is, and now I'm going to look at this part, this tells me my quotient that I put a box around, and this is my remainder that I circle. So the quotient is going to start at the 0 degree term on the right and work its way up a degree. So negative 26 is a 0 degree term, or a constant term, and 4 is a degree 1 term. So these are my coefficients. 4x minus 26 is the answer when I divide those two polynomials, but there is a remainder, so I add the remainder over the divisor. And this is my answer to that division. And I'm going to show you the long division method. The long division method always works, but is generally a little longer. When you can, when it's in this form, you should use the synthetic division because it's much quicker. So once again, doing the same division problem the alternate way, I divide 4x squared divide x to get 4x. So that's the divide step. I multiply at 4x times x to get 4x squared. But I multiply both of that. Now I have to take the 4x times the 3 to get the 12x. And this is a plus sign, so that's a plus sign there. Then I subtract that polynomial I just got, the whole polynomial, from the top polynomial. So I'm subtracting the like terms. 4x squared minus 4x squared is 0. That should happen. Negative 14x minus 12 is negative 26x. You may start to see some parallels to our synthetic method. And then we bring down the next term, the plus 4, and now we're going to repeat. So now I'm going to go back to divide. I'm going to divide negative 26x by x, and I'm going to get negative 26. And then I'm going to multiply that. I'm going to get negative 26x minus 73. And then I'm going to subtract. So when I subtract these, the negative 26x minus a negative 26 becomes 0. And positive 4 minus a negative 73. So again, I'm going to distribute the subtraction. I'm going to change it to plus, change it, change it. I distributed the negative to both. Those cancel to 0. 4 plus 73 is, no, I'm sorry, that should be 78. 4 plus 78 is 82. And there's nothing else to bring down, so that's my remainder. So look, my answer is 4x minus 26 plus my remainder over my divisor. The divisor was out here. And that's how you do long division and synthetic division. Now, if we tie this to what we have talked about, I could ask this question. Is negative 3 a 0 of the function that it's being divided by? So if I looked at the dividend, 4x squared minus 14x plus 4, and thought of that as a function, is negative 3 a 0? Well, look. If I put negative 3 in, I don't get out 0. I get out 82. So no, it's not. And if negative, another question I could ask is x plus 3 a factor of the dividend? The function 4x squared minus 14x plus 4. So in other words, could you factor 4x squared minus 14x plus 4 where x plus 3 is one factor, and then there's some other factor? And the answer is no, because there's a remainder right here. When I divide them, I don't just get 4x minus 26. I get a remainder. And that's what factoring means. When you divide one by a factor, you get another factor that has no remainder. So if I look at some of these first examples I did, so like this one, when I divide x squared minus 2x minus 15 by x minus 5, I get x plus 3. So that tells me, since I divided them and I got another factor with no remainder, a remainder of 0, I could say x plus 5 is a factor of x squared minus 2x minus 15. I could also say x plus 3 is a factor because it factors to this. Those are the two factors. And what goes with that, so I'm sorry, it's not x plus 5, is it? It's x minus 5 is a factor. X plus 5 wasn't. Sorry about that. X minus 5, when we divide it by x minus 5, it is a factor. And that means x equals 5 is a 0 of the function x squared minus 2x minus 15. Because I just showed over here, if I put 5 in, I'll get 0 out. And if I put 5 in, I know that x minus 5 is a factor. And likewise, I could say x plus 3 is a factor, and negative 3 is a 0. So there's a lot of deep concepts here. See if I have one cleaned up that shows it all. No, I don't. But here again, you can see when I divided by x plus 5, I got a remainder. So x plus 5 is not a factor, which means negative 5 is not a 0. But in this one, when I divide by x minus 5, I get a remainder of 0, which means x minus 5 is a factor, and 5 is a 0. Okay? So why don't you try a couple division problems here. We did that one. So why don't you try this problem, A and B. Try one of them with long division and the other one with synthetic division, just to practice both of those. Or if you want to try them each way, that'd be fine too.